Hey, section of the topic today, inverse functions, section 2.6 in the textbook. So remember, going right to Algebra 1, Algebra 2, Trig and Precalc, inverse functions. They are related to each other because the x and y values, inputs and outputs, are switched with each other. When you graph them, they're reflected over the line y equals x. So we're going to look mainly at the derivative. We're going to see some play with those relationships, inputs, outputs switched, and reflection over the line y equals x. The derivative of an inverse function, this big blue box, I find this right here is the most helpful for me for remembering derivative of an inverse function. This topic comes up once or twice, or a couple of times, a few times on the exam, so being familiar with it, being able to recall it, but it's not one of the most important things ever, okay? Let's look at example 5. So what is the value of f inverse of x when x equals 3? So when this x value is 3, that would mean the original function, the y value, is 3. Because remember, x's and y's switch with each other. Got a pretty good suggestion from my wife. Got tea with honey. Hopefully I can cut back on the cough drops. So our y value for our original fx is 3. So solving that, add 1 over, multiply by 4. So 16 equals x cubed plus 4x. One number cubed plus 4 times that number is 16. Pretty small number. It's going to be 2. So f of 2 equals 3. So if you switch inputs and outputs, f inverse of 3 is 2. And you have your answer right there. So now what is the value of f inverse prime of x when x is 3? So again now, just looking at the derivative of our inverse function. So let's write our formula down first. So f inverse derivative of x going to be 1 over f prime of f inverse of x. So now we want f inverse prime of 3. So plug in 3 for all the x values, f prime, f inverse of 3. Based upon our answer from part A, f inverse of 3 is 2. So now we need to know f inverse of 2. So let's go back up to our original problem, fx. Let's go ahead and get a derivative. So f prime of x is going to be 3/4 x squared plus 1. So if we plug in 2, f prime of 2, 3/4 times 2 squared, 3/4 times 4 is 3, plus 1 is 4. So we end up with 1/4, or 1/4. And in part B, we see the relationship when a function is reflected over the line y equals x. That's a pretty poor sketch. That's better, okay. So with f and f inverse, so f of x and f inverse of x, x and y are switched. If we look at their derivatives, so f prime x and f inverse prime of x, we see the relationship that their slopes are reciprocals. So, kind of remembering those properties, if you're looking at just f inverse, x and y swap, f prime, f inverse prime, slopes are reciprocals. This formula I've circled is, for me, the easiest to remember. Take a look at example 6. Check your work with blank and please notes online.